Hello. Um, Today I'm going to be presenting on uh, Combat 429s. And essentially, what a 429 is a HTTP server error code. So uh, when a server gets too many requests from a specific IP address, it can respond back to that IP address with a 429 too many requests error. What I did was make a mini project that got into building a a sub feature that could be used in a larger software program for being able to deal with third-party web services that would be rate limiting or sending back 429s because the main software system is making too many requests. So there's a game that is played where the main software system, doesn't want to make too many requests, but it also wants to um, identify what the rate limit is for requests and sit right above it with its requests. So the software system can be as efficient as possible and can perform better. A real world scenario for this and kind of a background for the feature would be a export to PDF feature. And it makes sense, or an export to PDF feature, and let me give a little more background first. So um, if a user wanted to export their drawing, say it's a browser drawing program, the browser would submit a request to the third-party web service that does these PDF exports, and something may go wrong, and in that case, the programming would be to send to the backend system an export job for that drawing, and the the backend system would have a queue of these export jobs, and um, there's this desire to know what the third-party web service's rate limit is and sit right above it because um, more of these jobs can be processed quickly or as quick as possible. End game user is happier because they're getting their export faster, and perhaps this is what helps with generating revenue because the the end user is getting a better uh, service from the software company. So that's the big picture. Um, let me look at my outline here about what to get into next. Okay, so now I'm going to whiteboard out how a bit more of the details, a bit of a mid-level view of how this backend system would work, how the rate limiting uh, detection would work, and one other thing actually to show first is this. So 429 errors are not, they're not, it's not mandatory that 429 errors report the rate limit or the retry after time. The responses should include details explaining the condition and may include a retry after header. Okay. So not all servers, third-party web services, or no third-party web service is required to report what their retry after time is or what their rate limit is. So in our case, the browser join program, the export to PDF third-party web service is in the camp of third-party web services that is not reporting a retry after header. The user, so user wants export fails. So server receives export job, right? And there's going to be an export job queue. So job pushed on to back of export job queue. Now what we can do is let's look at how things look from the export job queue. Essentially, there's really only two states. A new job arrives if it's empty, and there's a processing of the job, or a active job finishes and there is more jobs in the queue, and there's a processing of the next job. So essentially, it boils down to processing new or new. One second. Processing new job or existing job. I want to add this. So I did you know, a code project here. So I have some code I'm going to show. I'll whiteboard out the database aspect in design, but I didn't code it out. So when the server receives an export job pushed onto back of export queue, another part would be job persisted to database. So export job queue, it will either process new job or existing job. So it really then boils down to process job. Process job. Send job to third party. And we could have a success case or an error case. All right, success. Number 1. Email or notify user with export. Put a star next to it because this is like a core attribute compared to other aspects. And remove job from database. It'll be important here to mention, the database part is, of course, important. In the case of the server crashing, then the jobs can be regained by filling the queue up with what exists in the database for jobs. Oh, and okay, so here now we'll get back into the rate limit discussion. So if there's a success, we're going to lower our rate limit. So we, had a set time between this current job and our previous job. So previous job happened, we waited the rate limit time, then we did this job. In the case of success, that means that our rate limit time, or the time we waited between calls, can be lowered. It can be optimized. Lower our rate limit / optimize. Great. Now, if we get an error, well, of course, it could be not a 429, but we'll look at 429 first. Okay, 429. Of course, put the job back on the queue. And raise our rate limit. I say our rate limit because the third-party web service has the actual rate limit, as a configuration constant in their software. One thing to mention too is, we could say handle non-429s. We'll leave that up for someone else to think about, but I'll mention that one enhancement might be to have an attempts count. So if a job keeps on getting put back into the queue, we don't want it to be in there forever. There's probably some bug with the file that's attempting to be exported, right? So perhaps in that case, if the attempts count reaches some value, perhaps 3 attempts, then remove it from the queue, remove it from the database, and email quality assurance or engineering with the file and flag it as being potentially um, carrying a bug. Alright, so that is the mid-level view of the export jobs queue system. Give me 1 second. Okay. Now I'm going to go down to a lower level view and get into the rate limit algorithm. So I was thinking about this and I was testing out how to make it work. And I came upon, of course, some bugs with the initial algorithm. So here goes. We're going to have some rate limit, and there's an actual, which I'll put down here. Actual rate limit. I don't know. 1750 milliseconds to be exact. Let me say, gosh, I don't know. I don't know. The industry's real rate limits. This is just make believe. But the algorithm is pretty good, I think, and I'll explain it now. So let's say the rate limit we start our server out at is 500. Now, if I send out one call, start tracking my rate limit because I send out one call, the third party processes it. That comes back successful, and then I wait 500 milliseconds and send out the second one. Well, that's going to fail, right? Because the actual rate limit is 1750. So maybe my thought was, just raise the rate limit if the rate limit doesn't work at first by some value. So I decided to have it be 1,000. So raise it by 1,000 until we find the rate limit. So, or make it 1,500. Raise it by 1,000. It won't work. Raise it again. So 2,500. This works, right? But it can be optimized. And my thought was, well, we have a recording of what didn't work. Why not, get the midpoint value between these two values? This value right here being the highest error rate limit, and this value being the lowest success rate limit. And what this leads to is actual properties in our code, which I use for the algorithm. So, given my marching through the trying out of rate limit values, it becomes 1,500 as highest error rate limit, and lowest success rate limit is 2,500. Right. So 2,500 works. It can be optimized. We're going to try and find the optimization. um, go to the midpoint between 2500 and the highest error rate limit, 2000. That works because it's greater than the actual rate limit. So we record it as the lowest successful rate limit because we can use it later when we need to find the midpoint between rate limit and lowest successful rate limit later on, potentially. Because it worked, we want to deduce the rate limit to optimize it so we can, have higher throughput of requests. So we do the midpoint between 2000, which is our current rate limit, and highest error rate limit, which is 1500. That's 1750. And it works, right? Here, I'll do this too. Doesn't work, doesn't work. Worked. We're going to encounter an issue, and I'll explain. So, 1750, we want to deduce it. We don't know what the actual rate limit is. We hit it on the nose, so we want to deduce it to optimize. 1750 to 1500. That's 250, so 125, so 1625. Doesn't work. Okay. $17.50. So now we go back the other way. Get the midpoint between 1625 and 1750. That's like 125. So the midpoint is plus 62 something. So 162.5 plus 62 is like 1687, or I don't know, something like that, approximate. Doesn't work. And you can see how we're going to approximate closer and closer to 1750 but not hit it, and this is not good. So my my fix in the code is to detect when the difference between the rate limit and lowest successful rate limit is less than like 100, and once we get to that point, lock in our rate limit from that point forward at 1750, or the existing lowest successful rate limit. And for completeness, because it's always very good with algorithms, I've found that when we start out at some rate limit k, I set the highest error rate limit initially to 0, of course, and lowest successful rate limit to null. And I detected for null if rate limit okay, so if actual rate limit was, I don't know, k plus 100, right? Then, in my first go, I am going to have an error because rate limit is less than actual, and I want to approximate towards lowest successful rate limit, but it doesn't exist. I basically, in that situation, just march k up by I don't know 100 until lowest successful rate limit found. So, you know, then it would be k plus 100. And then we would, rate limit would be the same as actual, and lowest successful rate limit would be recorded, and we would then do what I explained up the canvas here, which is out of view. Okay. One thing to mention that is important that I wanted to look into and did is that our rate limit is not the real rate limit, because it's the amount of time that the queue waits before processing again. So that time is not inclusive of processing time on both servers and messaging between servers. So let's diagram that out. Third party and us, right? We have a request go out to the third party. Third party has a last request time. Which we'll say is A. If now minus A is now minus A less than rate limit is the assertion. If it is, well, then it's going to report back at 429. Let's say it isn't, and it reports back it allows the processing, and it reports back a 200, an OK response, and sends back the export data. A changes to B, so the third party can keep track of last request time and has to update it for the next request, right? So on our side, we have this little period right here, which is our processing, right? Then we do a wait. Then we send back to the third party with our next request. Now minus B less than rate limit. Well, depending upon that assertion, do 429 or 200. So you can see that our server's rate limit, which determines the wait time here, you know, might be 500. The time between A and B, which is used for asserting against the rate limit on the third party, is something more like I don't know, let's say 550. On my computer with two local hosts talking to each other, it was only like 505. So it was only 5 milliseconds for all the messaging and non-wait processing to occur, and the wait was 500. Okay, so I wanted to explain that part. Now to get into some enhancements that go beyond what I coded out. So a little bit more here. So our server may run for a couple days. And the rate limit which we're trying to sit above is perhaps it starts out like here, and we find a good value right above it. Well, if we just uh-oh, gotta zoom out. Okay. If we just stay here into the first day, well, the rate limit on the third-party server, I don't know, but possibly could go down, right? So maybe every hour or every some value amount of time, we do a detecting of a rate limit that didn't work before, and we test the waters. And if that's the case that it still works, we keep testing until we find our equilibrium again right above the rate limit of the third-party server. And of course, we're going to want to follow that same process. Test the waters. Well, we're a couple hours past the last time we tested the waters. Third-party server may be lower rate limit now. So test the waters, do the same process, and keep going. And of course, it'll be very apparent if they do bring back up their rate limit, and we hit it, then we'd have to raise our own. If it goes back up, we hit 429s. Oh no! Raise the rate limit, lower it, until we find right above. Right? That's it. That is an enhancement I was thinking about. Okay, time to look at the code. Yeah, it'll be fun. So here is a task runner code that I did and like to go back to and use, and it's what I used to build the export jobs queue. I don't want to get into explaining it all, but I will include it in the GitHub repo, and this could be a good beginning point to then understand the export jobs queue code. let me say one part. So I'll just add works so that asynchronous, synchronous tasks are processed one at a time. So you can probably think and start seeing how this is useful for our rate limit detecting prototype. Number one, there's only one, we need to have only one job going at one time so that, you know, we don't go over our rate limits, right? And we can track and enhance our tracking of the rate limit. So yeah. Here is our server. I did some database code, like right here and here. Don't mind that. Here I'm importing my export jobs queue. I'm creating 7 jobs. And I'm posting to my third-party server, which I have on localhost 8081 at an endpoint of convert to PDF. I have some dummy data as the authoring data. This is the job. So it's a function that is not executed yet. It will be executed by the export jobs queue. Give me one more moment. Okay. And we're pushing it on here. And we see the third-party server. We're setting up the server, listening on port 8081. Rate limit is 500. Last request time is null. It gets set upon the first call. So the first call comes in, and this is the implementation for what to do with a call. The request data is of course here, and as you can see, you know, if time since last request is less than rate limit, response status 429 send. Else send back the data, and the 200 status is implicit here. I am losing my voice, so I gotta finish up. Here is the export jobs queue code. So I call it rate limit job runner, and gosh, yeah, there's a lot here. Just to touch upon what's going on. Where's the push? There it is. Push. We push on to the jobs array or queue call process. If we're not processing and there is a job on the queue and we're not in a waiting phase, which is the time between calls, so that we don't hit rate limit errors, then get the first job at the front of the queue using this shift call, and then call it. So that is the calling of this function or job. Upon completion, this is the callback or the done. Right here. So it calls done upon the job calls done when there's a reception of the response back from the third-party server with an error or not, and this handles um, either response. And as you can see, like if there's an error, we push the job back onto the queue because we got to reprocess it. Here is where we set new rate limit, which uses that algorithm of honing in on the optimal rate limit, which I explained in the whiteboard. Is tracking rate limit is the state of knowing that we can track the rate limit because we had an item in the queue and hit the server and then had another item right in the queue, so we could then actually track the rate limit. Here's the set new rate limit code, which is up here. And this code does that back and forth where if there's an error, it goes to the midpoint between the current rate limit and the lowest successful rate limit. If it's successful, then it goes to the midpoint between the current rate limit and the highest error rate limit. And here is where we do the locking. If the rate limit is locked, which is what I explained in the algorithm about 20 minutes ago now, then we just return. And we lock when the rate limit diff stopping point is the rate limit, or the difference between the lowest successful rate limit and the rate limit is less than the what I call the rate limit diff stopping point. So we don't have that bug I was showing in my dry run, which would be like a never-ending approximation of the rate limit, and it would keep airing out. You can see here I'm locking the rate limit and setting the rate limit, if the conditional is true, to lowest successful rate limit. Okay, that explains that. So let's actually run the code. Third-party server gets set up first. Node server third party.js. Node server.js. So we see the jobs are coming. I start the rate limit at 2,000. The third party's rate limit is 500. And let me screenshot this. Or 1 second. It's probably going to be hard to see on YouTube, so I'm going to zoom in on it. Okay, that might be easier to see. So, I don't think so. Darn. You know what? I gotta kind of read out what's here. I know it's going to be hard to see on YouTube, but basically, shucks. I want to include the rate limit. Or no. I want to log the rate limit. Okay, so I have 7 jobs going. And rate limit starts off at 2,000. Comes back, success. Of course, it works the first time. And then it's actually the rate limit is for the next call. So it's 2,000 for the next call. So success. 500 for the next one, success. 250 for the next one, error. Why? Because rate limit's 500. 375 for the next one, error again. And then 500 for the next one because we locked the rate limit at 500. And then success. So we have 9 total requests. And how many errors? 1, 2. And the amount of jobs we had are 7. So that makes that is me, making sure that my testing of the rate limit detecting prototype checks out. And that's that. As far as so that's it for my presentation. As far as next steps for the project, if I were to get into them, they would be unit testing, of course, completing the database code that I started, which you could even see me starting if you look at my GitHub. Doing a client side to make it even more real, so actually have the user try to export to the third party, and there could even be some great error handling on that side too, like what if there's never a response from the third party, well, in that case we would want to set a timeout, just a couple seconds ahead to detect if the response hasn't come back in, because timeouts take forever and could, if not handled, would lead to the user seeing a loading spinner for 50 seconds or whatever, because an error never happens from a timeout. Another fun next step would be to, I'm just looking at my outline here. Another fun next step would be to test my system that I have here with third party and our server being in different states, or thousands of miles apart from each other, or across the world, and start looking at, does it still work? What are some implications of longer distance to communicate messaging? And then reiterate and enhance the code so that there's coding done in regards to very long communication time between servers. Yeah. Okay, that's it for this one.